So here's a third example in lesson 3.7 that gives us some sort of a geometric connection. So you can see how this might apply in a setting that involves sides of a right triangle. So one of the things that we know about the relationship between the sides of a right triangle is that if you square the length of the two shorter sides, which we call the legs, and you add the squares of those legs together, they will equal the square of the longest side, which is called the hypotenuse. That's called the Pythagorean theorem. I know we've all seen it before. So a squared plus b squared is equal to c squared. We can use this to find the sides of a right triangle, given a description like we see here below. So it says, the lengths of the three sides of a right triangle are represented by consecutive, even, whole numbers. Consecutive means one right after the other, but even means that, of course, that they all would have to be even. So for instance, consecutive even numbers could be 2, 4, and 6, 4, 6, and 8, 8, 10, and 12. And what you notice is consecutive even numbers just keep adding 2. So if I decided that my first even number was a, then my second even number would be a plus 2, and my third even number would be a plus 4. 2 more than a plus 2 is a plus 2 plus 2, which is a plus 4. So if I come back up here to my right triangle, then one side is a, the other side would be a plus 2, and this is definitely not drawn true to scale. And then the hypotenuse would be a plus 4. We want to solve for a. And once we find a, then we know that the next leg is going to be 2 more than it, and that the hypotenuse will be 2 more than it. So a squared plus b squared equals c squared. A squared, our side b we called a plus 2, so a plus 2 squared equals c squared. And our c, our hypotenuse, we called a plus 4. So it equals a plus 4 squared. Looks more complicated than it is. We remember that when you square a binomial, it's just like take that binomial and